Hello, students of science. In this video, we're going to talk about how we determine chemical formulas. Previously, we talked about how we determine the mass of them and what usefulness they are. Here, we're going to talk about how we actually figure those out. First thing we need to talk about is something called hydrates. Hydrates are these crystalline ionic substances with water as part of their structure. All the time, water is going to be part of their structure. So here we have a methane molecule in the middle, surrounded by this almost cage of water right here. So we would call this a methane hydrate. This is part of the actual crystalline structure. You need the water in there. When you heat those hydrates, what you're usually going to be doing is you're going to be driving off that water. So when they lose their water, we call them anhydrous. And anhydrous means without water. So here I have hydrated cobalt chloride. When you heat that, the water is going to leave and you are left with anhydrous cobalt chloride. Now, naming is going to be the same as we've seen with other ionic compounds. The only difference is you're going to add on the little thing at the end, like a prefix, hydrate. And those different prefixes are going to be mono, di, tri, tetra, penta, hepta, hexa, etc., based on the number of water molecules that are going to be going there. So this one right here, there's going to be another simple molecule in the middle, and this one happens to be surrounded by 20 water molecules. So we're not going to go that high with our prefixes. So let's look at a couple examples here. We've got cobalt 2 chloride. Nothing there is new. You should be very familiar with how to name that. However, when we have 6 water molecules there, 6 is going to be hexa, so this is going to be cobalt 2 chloride hexahydrate. This one is going to be magnesium sulfate, and then we have 7 water molecules. 7 on here is going to be hepta, so it's magnesium sulfate heptahydrate. So you count the number of water molecules that are associated with each one of our compounds, and that tells you the name of that hydrate. All right, let's talk about empirical formula. The empirical formula is a chemical formula that shows the composition in the simplest ratio of its elements. I think right now I just want to jump and show you some examples. CH2 or HO or CH2O or C3H7. These are all simple formulas. You cannot simplify them any further because the subscript here is 1 and this one's 2. That can't be simplified down any further. So this is the bare end for what we can go. So that's what an empirical formula is. Empirical actually just means it's things that are based on observation and experience rather than theory or logic. And when you find this out in a lab, you first find out the empirical formula. You first find this one out. Observation and experimentation. Empirical is just, well, can it happen? And will you marry me? Let's find out. Apparently, yes. Get it? It's empirical day, whatever. The empirical formula is going to show the simplest integer ratio of the atoms in a compound. Think of this as like the chemical equivalent of the math concept of the lowest common denominator. What do they both have in common? Well, in this case right here, this is as far as we can simplify. And it's important to note, multiple compounds can have the same empirical formula. So we can get to one of these through more than one way. Molecular formula, this one's different. This is the actual chemical formula. You sometimes need to start with the empirical formula, but now we're actually getting into the actual formula for it. So it simplifies down to this, but this is what's actually going on there. You can't always determine this right away. So this is why you need to get the empirical formula first. To convert from empirical to molecular formula, you're going to use this kind of simplified equation there. X times the empirical formula is the molecular formula, where X is going to be a whole number multiplier, something that you're going to multiply the whole thing against. This one right here, this is hydrogen peroxide, H2O2, and the empirical formula is HO. In this case, X would essentially be 2, because this whole little empirical formula, there's going to be 2 of those. So here, this one right here, I have C12OH30, and then you multiply that by 2, and you get C24O2H60. So it's just kind of like a very simple math one there. So let's take a look at a molecular formula, C6H14. I can simplify that down to C3H7. That's almost at the lowest common denominator. And I can see that the whole number multiplier, X in this case, is going to be 2. C3H6, C4H8, putting these together, because those are important to note that they both have the same empirical formula. They both are CH2. It's just that this top one, and that's propane, has a whole number multiplier of 3, and this one down here, this is butane, that's a whole number multiplier of 4. H2O2, as I mentioned, the empirical formula is HO, and the whole number multiplier is 2. C6H12O6, glucose, the empirical formula for that one is CH2O, the general form of a carbohydrate, and the whole number multiplier is going to be 6. So that's the basic idea for empirical and molecular formulas.